Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and this is lecture number 25 for chemical kinetics. In this lecture I will explain about threshold energy. And we denote like this. Now, thermodynamically, when we explain any reaction with graph, it can be like this. Energy versus progress of reaction. Okay. Let us talk first of all about endothermic reaction. So we start with reactant and we don't know what is the amount of energy of reactant is, and let us call it energy of reactant, so ER. And in the beginning we have to give energy to the system, so reactants absorb energy while progressing the reaction, and therefore the graph goes like this. And reactant will absorb some amount of energy up to certain extent and they form activated complex now. So this is activated complex and the state is not either reactant or product, so we call it transition state. The energy of this reactant, also activated complex, we call it epsilon R star. Now, if collision occur in proper direction, then this activated complex form product on further extension of the reaction, and we may get product over here. For example, this is product, so the energy of product is known as EP. Okay, so in this condition the energy of reactant ER, suppose it is denoted by X. This is the line through which we can find out energy of activation, and for that here we put this range as Z, and the difference of EP and ER we call it Y. Sorry, Z could be here also. I made a mistake. This can be Z. The energy of activated complex and energy of product, the difference is called Z. Okay, so if it is the graph of endothermic reaction, then we can interpret this graph like this, that initial potential energy of reactant is equal to average kinetic energy of reactant and it is known as X, or ER. Okay. Now, potential energy of product is equal to X plus Y, which is also known as EP, energy of product. Now, energy of activation is equal to Y plus Z. It is also known as EA. For forward reaction, and energy of activation for reverse reaction would be Z for reverse reaction. It is also known as, I think Z is enough. I think you can see this. And from this we can say that it is equal to epsilon star minus EP. And delta H, that is heat of reaction, is equal to Y, which is EP minus ER, and as it is positive, it is endothermic reaction. Okay, or it is also equals to energy of forward reaction minus activation energy of reverse reaction. And then threshold energy, the amount of energy absorbed by reactant, maximum amount of energy absorbed by reactant is called threshold energy. At that time, the energy of reactant is called threshold energy, and that is epsilon star. It is energy of transition state. It is also equals to energy of activated complex, or X plus Y plus Z. Okay, so this is regarding endothermic reaction, and this is what a threshold energy means. Now we'll refer exothermic reaction. Okay, and for exothermic reaction, we draw a graph similar to this only. Here we have energy, and this is progress of reaction. Now we start with reactant. Suppose energy of reactant is something here. This is called ER. When reaction is in progress, energy of reactant increases. It will absorb some amount of energy and form activated complex. This is the highest energy absorbed by reactant, or it is called transition state. Now further reaction goes and we get product. So this is a product form and energy of product over here, EP. Okay, so let us identify different kinds of energy. This is epsilon star, energy of activated complex. Now here, first of all, let us define this as energy of product, EP, is equal to X. Energy of reactant and product difference is, say, Y. And this difference, we call it Z. Then initial potential energy of reactant is equal to average kinetic energy of reactant is equal to ER is equal to X plus Y. Potential energy of product which is EP is equal to X. Now energy of activation for forward reaction which is EA or is equal to Z or is equal to epsilon star minus ER. Now energy of activation of reverse reaction would be Y plus Z, which is equal to epsilon star minus EP. Okay, heat of reaction, say Y, which is EP minus ER, and here this is negative, therefore it is exothermic reaction, and it is equal to energy of activation energy of forward minus activation energy of reverse. Threshold energy of this reaction, epsilon star, is equal to X plus Y plus Z. So this way we can analyze different kind of reactions with respect to threshold energy. Thank you so much.